Good day, everyone, and welcome back to my pre-calculus class. We'll be studying chapter 7 in our textbook today, and we will be going through solving trig equations with identities. So we'll be returning to the study of identities. We will also look at sum and difference identities, study double angle, half angle, and reduction formulas, sum to product and product to sum formulas. Then we will solve trig equations and also model with trig functions. So let us start. Think about some movies you've seen in the past, whereby you would have, let's say, a spy who wants to go to another country. Although they are not from that country, but they will try to get the passports of that country so that they will be able to get into that country probably as a citizen or whichever the case may be. So, how does that relate to what we're about to study? There's a single person, just one person called, let's say, a spy who wants to go to country A, country B, country C, country D, and this one person is going to have different identities, right? So that is what we are trying to say here. We can have situations whereby we can write some trig functions or some trig expressions in different ways, and we call them identities. Okay, so that is what we are about to study. And to do that, we are going to be using some of the identities we have learned before this class, before this topic. For example, the Pythagorean identities, you remember these three. Then the quotient identities, we know tangents of an angle is sine of an angle divided by cosine of an angle, and cotangent is cosine divided by sine of angles. What of odd and even identities? We know that tangent, cotangent, sine, and cosecant are all odd functions. Only cosine and secant are even functions. We learned that. We also learn about reciprocal identities, how sine is related to cosecant, how cosine is related to secant, tangent to cotangent, cosecant to sine, the other way around. So we will be using all these known identities to manipulate or to rewrite trig expressions so that we can form newer identities from them. So let us see how we can go through this idea. Do you need to know these basic identities in your head? Yes, you have to know this in your head because these are the identities you will use in writing these bigger identities in their simplified form. Okay, let us start. This problem says verify the following identities. In this situation, you have been given, just like I would say, sine squared of an angle plus cosine squared of an angle is 1. Just like you've been given something like this, we were also told that tangent of an angle theta multiplied by cosine of an angle theta is sine of theta. Our job here is to verify that it is true. To do this, we are going to take one side and show that it is the other side, right? We will take one side and express it, simplify it, and in the end, we will show that the answer we get is exactly the other side. Now, we always want to start with the complicated parts. The reason being that it is easier to simplify than to build up. So, let us look at this problem. In this case, I will say from left-hand side. I'm starting from left-hand side because it is much more complicated compared to the right-hand side, which is sine of theta. So I will pick the complicated parts. I will simplify it. In the end, my answer must be sine of theta. That is what I want to do. I want to verify that it is sine of theta. Okay, this left-hand side, which is tangent of theta, cosine of theta, is the same thing as, now I need to go back to the basic identities I know. I use that to simplify this. Well, I know that tangent of theta is the same thing as sine of theta divided by cosine of theta. Then multiply by cosine of theta, which is equal to, in this case, I can say cosine here 1, cosine here 1. So my answer is sine of theta. So folks, you can see I have been able to get that same answer that I have here. So which is the right hand side. Verified. So verified. Done. Okay. Look at problem B. Well, like I said, we also want to verify this. So like I said, we always want to start with the complicated part. One is not complicated, but the right-hand side in this case. So I will say from right-hand side, which is cosecant of theta multiplied by cosine of theta multiplied by tangent of theta. Let us try to simplify this. I do know that cosecant can be expressed as reciprocal of sine. So I'll say this is sine of theta multiplied by cosine. You don't need to rewrite it. It's already in its simplified version. So tangent, I can write it as sine of theta over cosine of theta. Let us see if we can cancel some things out. Yes, cosine here 1, cosine here 1, sine here 1, sine here 1. Oh, all we have is 1 divided by 1, which is 1. And that is exactly our left-hand side. So I will say it is the same thing as my left-hand side. So verified. So again, look at what I did. I only pick one part. Then I simplified it and I arrived at the other side. That is very important because if I ask you to verify an identity, do not work the two together at the same time. You need to pick one side and show that it is exactly the other side. And the way to do it is pick the complicated parts. In this case, I would claim that the complicated part is the right-hand side. So from the right-hand side, I have 1 plus sine of x multiplied by 1 plus sine of negative x. The first thing I notice here is that this, I can rewrite it. Sine of negative x is the same as negative sine of x. since sine is an odd function. So I can rewrite that. So I will have this times 1. So that will become minus sine of x. I hope that makes sense to you because this is what I have now. So times positive there. So that is negative sine x. Let us see what we can do. Well, we can open up now. We can expand what we have here, and that would be, look at this, folks. We have a situation whereby we can say the answer is 1 minus sine squared of x. At this level, all what you need to do is just multiply this. 1 minus sine of x. So multiply this 1 times 1 minus sine of x plus sine of x times 1 minus sine of x. So that is 1 minus sine x plus sine x minus sine squared of x. So this will take care of this, and we have 1 minus sine squared of x. And remember, 1 minus sine squared of x, there is a relationship. We do know that cosine squared of x plus sine squared of x is 1, the Pythagorean identity. So if I move this to the other side, I will have that cosine squared of x is 1 minus sine squared of x. So that means here I will have cosine squared of x, which is exactly my left-hand side. That is my left-hand side. So verified. So let us quickly, let me write the steps I add here so that can make much sense to you. In this case, how did I move from here to here? I use the idea that sine is an odd function, which means sine of negative x is minus sine of x. That is what I did here. Then I expand. Then here I use the fact that cosine squared of x plus sine squared of x equals to 1, which implies that cosine squared of x is 1 minus sine squared of x. So that is my left-hand side, and our identity is verified. Okay, what about these? I will claim that the right-hand side is much more complicated than the left-hand side. I think that is obvious. So I will start from there. I will say from right-hand side, which is secant squared of theta minus 1 divided by secant squared of theta. Well, what can we do? Sometimes when you are solving problems like this, always think about, firstly, look at where you are going to. Then you think how you can get there, the fastest route for you to get there. In this case, I need something that will lead me to sine squared of theta. How can I get there from what I have here? Well, maybe if I do this, secant squared of theta divided by secant squared of theta minus 1 divided by secant squared of theta. Look at that. I can do that. I can separate that. Now this is 1 minus cosine squared of theta, since um, cosine of theta is 1 over secant of theta, reciprocal, right? So look at this, guys. If I have cosine of theta is 1 over secant of theta, it means if I square that, it only means I just need to square this as well. So that is why I can replace the whole of these by cosine squared of theta. All right. Now, look at this again. I can say this is sine squared of theta, since cosine squared of theta plus sine squared of theta equals to 1. So I know from this Pythagorean identity that if I move this to the other side, then I will be left with only this, right? So that is my left hand side. So verify. Okay. Now, um, uh, so let me state here that unfortunately there is no one way to do this. So that is why you should not memorize this topic. There is no one way to do this. All what you need is your ability to think on how you can simplify the situation. That is it. In this case, I will start from the left hand side, because it is much more complicated than 1, which is on the right hand side. So I have 1 minus cosine squared of x times 1 plus cotangent squared of x. In this case, well, let us see. I can say this is equal to maybe sine squared of x times, what about this? 1 plus cotangent squared of x. Remember, if you don't know this often, always remember this. Sine squared of x plus cosine squared of x is 1. What can I do to get cotangent? If I divide cosine by sine, so in this case by sine squared of x, I should get there. So I divide through by sine squared of x. So this is 1 plus cotangent squared of x equals to cosecant squared of x. I hope that is clear. So I can replace these two by, just 1 plus cotangent squared of x by cosecant squared of x. So cosecant squared of x, which is sine squared of x. I don't need to do anything to sine because it's already in its simplified form in a way. I know that cosecant can be written as 1 divided by sine. And in this case, now it will be sine squared of x. Again, guys, look at it. This here 1 and this here 1. So I can say it is 1, which is our right hand side. So verified. If you do not want to go through this, then you should know all these identities often. Look at it. 1 plus cotangent squared of theta is cosecant squared of theta. That is what we use when solving this idea. So you can see how all these basic identities are coming together to help us simplify you know, this complicated trigonometric expression. So you should pause this video now and try these problems. Try these problems. They are not as scary as they appear at all. They are not scary at all. Well, they look scary, but not difficult to solve at all. Just think about which one is the complicated part, then start from there. And in the end, you know that the other side is your answer. So the good thing is that we know our answer from the outset. So we are just working towards that answer. That is the whole idea. Okay. Now, another form is we can create identity. So in this case, we do not have left-hand side, right-hand side, and we want to use one to verify the other side. Or we want to simplify one side to be equal to the other side. We want to create in this form, meaning we'll keep simplifying until the very end. So in this case, we want to simplify this expression strictly in terms of sine. Look at it, we have tangent, we have secant, but we want to simplify it, and our final answer should only be in terms of sine of theta. Okay, let us see how we can do that. 2 multiplied by tangent of theta, secant of theta. Well, tangent, I can rewrite it as sine of theta divided by cosine of theta. That we know. What about secant? I can write it as 1 divided by cosine of theta. Okay. Looks like nothing is canceling out. What else can we do? Well, maybe we can multiply things out. So 2 times sine theta times 1, I have 2 sine theta divided by cosine theta times cosine theta, that is cosine squared theta. Oh, I know that cosine squared of theta plus sine squared of theta is 1. So if I make that the subject of the relation, I will have 1 minus sine squared of theta. So I can just replace everything at the denominator by 1 minus sine squared of theta. Done. I don't need to do anything again because my answer now is in terms of sine. No cosine, no tangent, no other trig function other than sine function. So I can stop. Okay. What about this? Let us see. Create an identity for the expression secant of x plus cosecant of x divided by 1 plus tangent of x. Again, we want to write it strictly in terms of sine. Well, let us see how we can do that. Is it possible for you to start a problem like this and you see that instead of it getting, simplified, you are making it much more complicated? It is possible. But when that happens, you need to pause a little bit and see maybe there is another way you could go that will make things easier or that will make you arrive at your destination as fast as possible. So let us see. This case, we can say this is, here I will just start writing what I know about each of these guys. For secant, I know I can write it as the reciprocal of cosine. For cosecant, I know I can write it as reciprocal of sine. I know that. Well, I know that here I can say this is Let's see. I can also say 1 plus maybe sine of x divided by cosine of x. I can do that. Oh, wow. What can we do? Let us take care of the numerator. So if we have 1 over cosine of x plus 1 over sine of x, I can say this is sine of x, sine of x plus cosine of x divided by cosine of x, sine of x. Now what I did, common, you look for the denominator, which is cosine of x, sine of x, then you just, or you do that whichever way you know how to and do such fraction. What I just did here is the same as you trying to solve something like this. Nothing fancy at all. Okay. Having done that, let us see. So meaning that for the numerator, I can say this is sine of x plus cosine of x divided by cosine of x, sine of x. For the denominator, let's see, 1 plus sine of x divided by cosine of x. Well, I can rewrite this part as cosine of x divided by cosine of x. I want them to have the same denominator, and that will be cosine of x plus sine of x divided by cosine of x, right? So I can write it as divided by cosine of x plus sine of x divided by cosine of x. I hope that makes sense. Next, I can say this is equal to sine of x plus cosine of x divided by cosine of x, sine of x times cosine of x divided by cosine of x plus sine of x. Now let's see if we can deal with some things. Look at this guy. Sine of x plus cosine of x is the same thing as cosine of x plus sine of x. And I have multiplication here. So meaning that I can say this guy here 1, this guy here 1. Done. Again, this is cosine of x times sine of x. So I can say cosine here 1, cosine here 1. And in the end, I am left with 1 divided by sine of x. Although I know that 1 over sine of x is cosecant of x, but I will not write that because the instruction is that I need to leave it strictly in terms of sine. So I will stop there. So you can see again, I started working, simplifying because I know where I'm going to. I'm trying to get to where the only thing I will have will be in terms of sine. So that is what I've been able to arrive at here. Okay, so let us keep going. Let us keep going. So pause this video and try to create an identity for this problem. Tangents, sorry, cosecant of cosine of x multiplied by tangent of x minus secant of negative x. What do you know? Remember, secant, is it an even or odd function? Whatever your answer is, how can you rewrite that? And then, how can you rewrite tangent of x? How can you rewrite secant of x? So, in the end, make sure your answer is having just sine function. Determine whether the following identity is true. This is another way we can ask this question. Let us go back to what we've been doing today. We started by saying verify. Verify. You have two sides. You pick one side, simplify it, and in the end, look up and see that it is the same answer that you have from the beginning. Then you stop. Then we said, okay, we can also create. So we have some expression, then we simplify it and we leave our answer in terms of whatever they want it to be or whatever the question wants it to be. Now, another form is to say, determine whether the following identity is true or false. If false, find an appropriate equivalent expression. This is similar to the first idea that we have, whereby we have both sides. But in this case now, it is telling you that, well, sometimes it will be true, sometimes it will not be true. Now, your task is to answer that question, if it is true or not. And for you to do that, you need to pick one side again, simplify, work it out. Maybe in the end, you can write it as the other side. Okay, let us start. In this case, I will start with the left-hand side, which is 3 sine squared of x plus 4 cosine squared of x. This looks like something that is familiar, like sine squared of x plus cosine squared of x equals to 1. But this is not going to help me because in the usual Pythagorean identity, here is 1, here is 1. But what I have here, I have 3, I have 4. So I need to think beyond that. Okay, what else can we do? Well, if I look at my answer, I see that it's in terms of cosine. Well, let me try to get rid of sine. Well, meaning I can rewrite this as 3. Remember that from this, sine squared of x plus cosine squared of x equals to 1, I can rewrite sine in terms of cosine. So that means I can have 1 minus cosine squared of x plus 4 cosine squared of x. I will not do anything to that because I know that my answer is in terms of cosine. So I will just leave it that way. So this is, I can open up, this is 3 minus 3 cosine squared of x plus 4 cosine squared of x. Now, I can combine these two. So this is 3 minus 3 cosine squared of x plus 4 cosine squared of x. So that will be plus 1 cosine squared of x, which is exactly what I have here. Oh, then I will say, therefore, the expression, the expression 3 sine squared x plus 4 cosine squared of x equals to 3 plus cosine squared of x is true. It is true because I was able to get that right-hand side or that other side. Okay, let us see. Let us see if we can do the same thing to this. Let us start. Again, I will claim that I'm starting from left-hand side because it looks much more complicated to me. So, secant of theta plus tangent of theta divided by cotangent of theta plus cosine of theta. Let us see if we will be able to simplify it and get secant squared of theta. Well, I have secant here. Maybe I shouldn't do anything to the secant I have there. I will leave it. Um, or sometimes I still need to simplify it so that I will be able to get out of some situation. Well, let's see. Maybe I can write this as this plus then sine of theta over cosine of theta. Why is your teacher using the word maybe? Like I said the other time, there is no one way to getting this done. There is no one way. You just need to try to use all the tools you have to see if you can write it. So that is what makes it interesting to me. So for cotangent, I can write it as cosine of theta divided by sine of theta plus, well, there is nothing to do to this because it is what it is. Okay, I will continue from this side equals to, for the numerator, just like we did the other time, I can have 1 plus sine of theta divided by cosine of theta divided by, so for this part, that would be cosine of theta plus cosine of theta sine of theta divided by sine of theta. You can just pause this video and try to solve this. Cosine of theta divided by sine of theta plus cosine of theta. Just solve this. I can multiply this by sine of theta so that I have the same denominator, and in the end, that is what I have. It's as simple as that. Okay, moving on. Let us see. Well, I know I can still take a step. Divided by cosine of theta times. And remember, every step you take forward in maths, you have a point. So cosine of theta plus sine of theta. So let us see what we can do. Nothing seems to be canceling out, but I observe one thing. What if I factor something out? The cosine of theta times sine of theta divided by, I can factor cosine of theta out, then I have 1 plus sine of theta. Oh, feels like I can do something. 1 plus sine of theta, 1 plus sine of theta, gone. Good, interesting. So we have sine of theta divided by cosine squared of theta. Or maybe I could see something. Let me show you what I saw. I can say 1 over cosine of theta times sine theta over cosine of theta. Okay, I can do that. And in the end, this is secant of theta times, this is tangent of theta. So I am unable to get to this right-hand side. How do I know that because this is, everything here is already in their simplified form. So looks like there is nothing I can do again. So I can just say that expression I have there, the expression, the expression secant theta plus tangents of theta divided by cotangents cotangent of theta plus cosine of theta equals to secant squared of theta is false. Not true. That identity is not true. So what is true is that we must have that secant theta plus tangent of theta divided by cotangent of theta plus cosine of theta is equal to secant of theta tangent of theta. So that is a possibility. That is a possibility. Yeah. Okay. So maybe another possibility is something like this. Sine of theta divided by cosine squared of theta, right? So which is equal to sine of theta times secant squared of theta. Because I can write this as sine of theta times 1 over cosine squared of theta, which will give me secant squared of theta times sine of theta. So that is also a possibility. That is also true. So there is no unique answer here. Okay, so that is that about using the concept of identity. We have used it to verify, we have used it to create, and we now use it to answer if some identities are true or not. Now, we will start this section, sum and difference of identities. So in this place, we'll be looking at situations like this. When we have two angles added together and we want to find the cosine. Here is the formula. I will give you the formula without proving the formula. Yes. I don't want you to get bored, but there is a way we get to this. So you can check the textbook, our textbook, if you're interested in learning about the proof, or you can, if you're interested, you can come to office hours and we talk about it. But in this video, I'm just going to use the formula. So when we add two angles together and we want to find their cosine, then the formula is cosine of the first angle multiplied by cosine of the second angle minus the sine of the first angle times sine of the second angle. Please watch this. For cosine, when it is addition here, here is subtraction. And when it is subtraction here, it is addition. And also notice that for cosine, it is cosine, cosine before sine, sine. Okay, for sine, it is the other way around. For sine, it is sine, cosine, then cosine, sine. That is sine of the first angle multiplied by cosine of the second angle plus cosine of the first angle times sine of the second angle. And when here is plus, for sine, here is plus. When here is negative, for sine, here is negative. So this is something you can put on your cheat sheets for tests or for, you can look it up for quiz. You don't need to memorize this. They are standard formula, so you do not need to memorize. You can either know it by heart, like, okay, you know how it works, or you just put it on your cheat sheets for exam. Okay. Let us take example. Find the exact value of the following expression. So here I am going to adjust this problem to using sum and difference of angles, because I do know that some of you may think that, well, teacher, can we not just subtract the angle and just do what we have been doing all this while? That is true. But we want to use this idea of sum and difference of angles. And I will tell you why this method is important. For example, if I ask you to find the cosine of, let's say, 105 degrees, this is not a special angle. We do not have it on the unit circle. So we can use this idea because I can break this down into, let's say, 60 plus 45 degrees. So I can do that and use this idea. So if you go ahead to add this and have 105, you will see that you will not be able to do it. So that is why this method is important. So in a way, this method allows us to find the cosine and sine and tangent of angles, of some angles, not all angles, of some angles that we cannot find on the unit circle. You see the story we have been telling. Let me remind you the story we have been telling in this class. We started with our dear friend, the unit circle, and we say, well, this is 1, 0, this is what's it called? This is 0, 1, this is negative 1, 0, this is 0, negative 1, right? And we say, okay, this is 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi. We also have 30 degrees, we have 45 degrees, we have 60 degrees, or pi over 6, pi over 4, pi over 3. We have all those. Then we have other angles like 135, 120, 150, 180, and so on. But we are still missing some angles. For example, 75 degrees. We don't have it as a special angle here, 75 degrees. We do not have it. 105, we do not have it. So we should find a way to get to these other angles. That is what we are doing now. Okay. Okay, let us continue. Now, in this case, we have, this is cosine, and here is negative. Let me remind you, when we are taking cosine of something like this, what I need to do is write cosine of my first angle times cosine of my second angle plus, because this is minus, plus sine of my first angle times sine of my second angle. As simple as that. Therefore, here that means I will have cosine of my first angle, 5 pi over 4, multiplied by cosine of my second angle, plus sine of my first angle, multiplied by sine of my second angle. Right? Yes. So let us solve this. Now we are at a place where you already know what to do now. So what is cosine of pi, 5 pi over 4? By now, maybe I should say you should know all this in your head or how to get there in your head, right? 5 pi over 4. So remember, let us try. Maybe we can do without unit circle. Let us see. 5 pi over 4. That is 5 of pi over 4. In the first quadrant, we have 2 pi over 4 there. By the time we get to second quadrant, we have 4. The meaning we will get into the third quadrant to have the fifth one. And now I can claim that in that third quadrant, well, cosine is negative there, or let's say x value is negative there. So that would be negative root 2 over 2. Or you can use your unit circle to find that. Multiply by cosine of pi over 6, that is in the first quadrant, pi over 6, that is 30. So the cosine there is root 3 over 2 plus sine of 5 pi over 4. So again, you are in the third quadrant. So sine is negative there. So that is also root 2 over 2 times sine of pi over 6, that is 1/2. So that is equal to negative root 6. You can multiply radicals like that, divide by 4, plus times minus, minus, root 2 times 1, root 2, divide by 4. So this is, I can say this is negative root 6 minus root 2 over 4. I can leave it this way. Mind you, do not say root 6 minus root 2 this way that it is negative root 8. No, not true. We cannot do that. Okay. So that is that. If everything went well with my arithmetic, then that should be the answer. Now, what about this? 7 pi over 12. Let us think. How can we rewrite this? We cannot find this angle on the unit circle. We cannot. Then we say, let us see if we can rewrite it as sum or difference of two angles. Look at this, guys. 7 pi over 12. Can I write it as, I just need to be smart. I want the denominator to be 12. So, okay, I want my denominator to be 12. And at the same time, I want it to be something I can make reference to in the unit circle. So maybe I can have 4 and 3. Let me try pi and pi here. Pi over 4, pi over 3. Let's see. This is 12. This is 3 pi plus 4 pi. And that is 7 pi over 12. Good. It works. So I just need to come here and say I can rewrite this as cosine of pi over 4 plus pi over 3. If that is not easy for you to come up with, another way to do it is convert 7 pi over 12 to degrees. So that is 7 times 180 divided by 12. 12 here 1, 12 here 1. I have 6 in 60. That is 5. So 7 times 15. That is 5, 3, 10. That is 105 degrees. Then I know, oh, I can say 60. Then 45. So which is pi over 3 plus pi over 4. So I can use that. So whichever one appears easy for you, can use it. But like we have answered in this class before now, when a problem is in radian, make sure you solve it in radian. So I only show you that you can get ideas using degrees. Then you bring it back to radian form. Okay, so here I can say cosine of the first angle multiplied by cosine of the second angle minus, how do I know it is minus? Because here is plus and it is cosine, minus sine of first angle times sine of second angle. So equals to cosine of pi over 4, that is root 2 over 2, times cosine of pi over 3. Cosine of pi over 3, remember, pi over 3 is up there in your unit circle, and cosine is x value, which is the shorter part. So that would be 1/2. Minus sine of pi over 4, root 2 over 2, times sine of pi over 3. Sine of pi over 3 should be root 3 over 2. So this is root 2 over 4 minus root 6. I can multiply that over 4. And my answer will be, so this is equal to root 2 minus root 6 over 4. Answer. If you want to know if what you are doing is correct, or say, wait, is this formula really true? Just put this in your calculator. Put this in your calculator. Whatever you get, it's going to be in decimal, something like that. Record it, save it, then put this into your calculator. It's going to give you decimal. Whatever you get should be the same thing as what you have here. It should be. Okay, moving on. Cosine of 75 degrees. Well, this is in degrees. Again, we cannot use calculator, so that is why we are looking for some manipulation. We cannot get this directly from unit circle. Here I can say this is cosine of maybe 45 degrees plus 30 degrees. So again, that is, I should, so let me change this to sine, because I've not used sine since. Let me change this to sine. Okay, I will change that to sine. I've not used sine since, so let me do that. Okay, sine of 45 degrees plus 30 degrees. So in this case, I will have sine of, so I'm using sine. So that is sine of my first angle multiplied by cosine of my second angle, plus, because it is sine and here is plus. So here will be plus. Now it will be cosine of the first angle multiplied by sine of the second angle. So which is, what is sine of 45 degrees? Well, always root 2 over 2. Cosine of 30 degrees, that is root 3 over 2 plus cosine of 45 degrees, again, root 2 over 2 times sine of 30 degrees, 1/2. So that is root 6 over 4 plus root 2 times 1, root 2 over 4. And our answer is root 6 plus root 2 over 4. That is our answer for sine of 75 degrees. Now you see, we have increased the angles we can find, even though we cannot find 75 degrees directly from our unit circle, but we are still, having a way to get to that. Okay. So briefly, let us also solve this. Yeah, sine, I have sine here, which is negative here. So I will do the same thing. This is sine of my first angle multiplied by cosine of my second angle minus, because it is sine, so minus this going to remain as minus. But then this will be cosine of my first angle multiplied by sine of my second angle. So sine of 45 degrees, root 2 over 2, cosine of 30, root 3 over 2, minus root 2 over 2, sine of 30 degrees, that is 1/2. So that is root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. So what we want to do is we want to evaluate these two problems and show that part A equals to part B. Why do I care? Well, you will see that 45 minus 30 is 15 degrees. 135 minus 120 is 15 degrees. Telling you that whichever way you... So suppose I ask you, what is sine of 15 degrees? Don't panic. Wait, I can get this from the unit circle. But remember, you can write it as 45 degrees minus 30 degrees or as 135 degrees minus 120 degrees. Do not write it as 75 minus 60 because you cannot get this. You will still need to rewrite that. So be smart when you are trying to think about how you can write it. But in this problem, I just want to show you that they're the same. So again, I will apply the formula. So this is sine of my first angle multiplied by cosine of my second angle minus, because it is sine, so it preserves that. Cosine of my first angle multiplied by sine of my second angle. So equals to, what is sine of 135 degrees? So you can go to your unit circle to find that because we can find it there. So sine of 135 degrees, that is pi over 4 times 3. So I will have it in the second quadrant. So it's going to be positive. So that will be root 2 over 2. Cosine of 120 degrees. So I will have it in second quadrant. That will be, the reference angle will be 60. So that will be, and cosine is negative there. So the reference angle is 60. And for cosine of that, that is 1/2. You can just use your unit circle to get all those values. There is nothing fancy there. Okay, cosine of 135 degrees. So cosine in the second quadrant, that is, I need to be careful because of that negative. So cosine of 135, so that would be negative root 2 over 2 times sine of 120. So that would be root 3 over 2 sine of 120 degrees. 120 degrees, pi over 3. So pi over 3 back here. Sine is positive there. Pi over 3, the sine of it. So yeah, that is correct. Okay. So this is negative root 2 over 4 minus times minus plus root 6 over 4. So this is the same thing as positive root 6 minus root 2 over 4, which is exactly what I have here. So just to show you that they will be the same thing no matter what. All right. Let me solve one more example, dear, before I allow you to pause this video and think, is this really big? We just worked on problems that, have inverses, composition of functions. Let us see, how can we undo this? Teacher, can I just say, let me use the formula directly? You can do that. you can also be smart to reduce it. What do I mean? I can call this old guy, I can call it A, and call this old guy and call it B. Because then I have cosine of A plus B, trying to minimize the complexity. So I can say let's cosine inverse of root 2 over 2, the A. So that means that I'm looking for some angle A such that cosine of that angle is root 2 over 2. So what is that angle? Well, it turns out that A is pi over 4. Remember the restricted domain for cosine, which is between 0 and pi. So that is where I can have pi over 4, right? So also, I will do it here, sine inverse of root 3 over 2 be B. So meaning I'm looking for some angle B such that sine of that angle will be root 3 over 2. So we do know that we will have something like, so the sine of it will be root 3 over 2. I believe that should be sine there. Okay, that should be pi over 3. That should be pi over 3. And on the other side, that should be 2 pi over 3. However, 2 pi over 3 is not in the restricted domain of sine that enables us to find the sine inverse. So I would say B, that angle should be pi over 3. This idea is from our last lesson. So it turns out that cosine of this big stuff, cosine inverse root 2 over 2 plus sine inverse of root 3 over 2 is the same as cosine of A plus B, which is the same thing as cosine of our A is pi over 4 plus our B is pi over 3. So we can use our formula now, which is, this is cosine, so that would be cosine of the first angle multiplied by cosine of the second angle. This is plus, it will become negative because we are dealing with cosine. Then sine of the first angle multiplied by sine of the second angle. So you can see we can return to unit circle for help. So this will be root 2 over 2 times cosine of pi over 3. Cosine pi over 3 is up there. Pi over 3 is, when I say up there, I mean in my unit circle, I'm referring to somewhere there. Yeah. Because I know there, my x value is shorter than my y value. That's what I mean by, so here is 1/2 comma root 3 over 2. So like I told you, nothing to memorize. You just need to know how things move around and just have fun with it. Okay. Cosine of pi over 3 turns out to be 1/2 minus sine of pi over 4. That the easiest, root 2 over 2 times sine of pi over 3. That is root 3 over 2. So this is root 2 over 4 minus root 6 over 4. And our answer is root 2 minus root 6 over 4. Answer. So that is that, guys. It looks, what is this? But at the end, it is nothing special. It's just bringing our last class to the idea we just learned today, combining the two together. So that is it. So you can go ahead to work on this, try it. Oops. Okay. Okay. Um, so this is try it. So you should work on this try it. And you have how many here? Three. You have three here. So pause the video, go ahead and work on this try it. So the same thing we did for sine and cosine. Briefly, let us do that for tangents. So quickly, let me show you tangents of, let's say we have angle A plus angle B. Remember that I can rewrite this as sine of angle A plus B divided by cosine of angle A plus B. I can rewrite it that way. And I know the formula for sine, the sum of angles for sine, that is sine of the first angle multiplied by cosine of the second angle plus, because it is sine, cosine of the first angle multiplied by sine of the second angle divided by, for cosine at the denominator, it is cosine of the first angle times cosine of the second angle. That is plus, it becomes minus here. So sine of the first angle times sine of the second angle. Beautiful, right? What can we do? Look at this. I'm trying to work towards tangents. What can I do? I know that if I divide sine by cosine, I can get tangents, right? Okay, look at it. Sine by cosine, I can get tangents. Okay, let us do something. Then I will say divide through by cosine of A, cosine of B. You will see why we did that. I want to divide each term by this. So we have sine of A, cosine of B divided by cosine of A, cosine of B plus cosine of A. Okay, I should write everything divided by, then everything divided by, I have cosine of A, cosine of B minus, so divided by sine of A, sine of B divided by. So now I'm dividing each term by cosine of A, cosine of B, cosine of A, cosine of B, cosine of A, cosine of B. Let us see what we have. Let us see what we have. This is equal to, for this part, well, this guy will take care of this guy. So I have sine A divided by cosine A. That is tangent of A. Plus, here, cosine of A will get rid of cosine of A. So I'm left with sine of B divided by cosine of B, which is tangent of B. Divided by, here, cosine of A will get rid of cosine of A. Cosine of B will get rid of cosine of B. So I have 1 minus, here, nothing is getting rid of anything. So I can say sine of A over cosine of A is tangent of A. And sine of B over cosine of B is tangent of B. So I've been able to write everything in terms of tangent. So when I'm adding two angles, I can use this formula. What if this place is negative? Let me use that. Oh, shoot. This is plus originally. So what if this place is negative? All I need to do is change this place to negative and change this place to positive. Done. Okay. Let me change. Let's see this. All right. So let us take example and try to end this class. Um, find the exact value of tangents of pi over 6 plus pi over 4. So that is, again, using that formula, that is tangent of the first angle, pi over 6, plus, because that is plus tangents of the second angle, pi over 4, divided by 1 minus tangents of the first angle times tangents of the second angle. So I can do that. And now we have equals to, what is tangent of pi over 6? So remember, tangent of pi over 6 is sine of pi over 6 divided by cosine of pi over 6. So which is sine of pi over 6 is 1/2 divided by cosine of pi over 6 is root 3 over 2. So that is 1/2 times 2 over root 3. So which is 2 here 1, 2 here 1. So that is 1 over root 3, which becomes root 3 over 3. By now you should know that often actually, just like you know sine of pi over 6 often. So plus pi tangent of pi over 4. Well, sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. If you divide it, you have 1. So that is easy. 1 minus tangent of pi over 6, we just find that to be root 3 over 3. And tangent of pi over 4, we just find that to be 1. So we have root 3 over 3 plus, okay, let us, for the numerator, that would become root 3 plus root 3 plus 3 over 3, I believe, divided by, for the denominator, that is 3 minus root 3 divided by 3. So we have root 3 plus 3 divided by 3 times 3 divided by 3 minus root 3. 3 here 1, 3 here 1. So in the end there, we have root 3 plus 3 divided by 3 minus root 3. Teacher, can I leave my answer here? Well, you may, but you won't have, you will lose some points because we know that we do not want to leave the radical in the denominator. So we need to rationalize. We need to rationalize the denominator by multiplying by 3 plus root 3 over root 3 plus root 3. We want to do that. So equals to, here we have, so I can claim that up there is 3 plus root 3 squared. I can claim that divided by, for the denominator, that would be 9 minus 3. And our answer is 3 plus root 3 squared divided by 6. You don't need to go for that. That is fine. Because we are sure that we do not have radicals at the denominator. So that is fine. So you should go ahead and solve this. Try it. And let me see. Okay, I will stop this video here and record another video to complete this work. So I will call that video part 2. I don't want this to be too long. So, guys, I will see you in the next video. I hope you have fun with this. Bye for now.